problem 6-110. Here you have a moment. It's going around this line here, this axis that's in the YZ plane. First thing to do is determine what direction it will go along each of the major axes. Here, if you transfer this, and I would use my thumb going in this direction, you can tell that this moment is going to go back this way in the Z. Do the same thing in the Y. You can tell it's going to go back this way, like this, with this being the point here and the Y. Go ahead and calculate what those would be. In this case, we'd know that mz is going to equal to the moment, m, here, times the cosine of 45 degrees, which will give me 0.7071 m. And do the same thing with my, which will equal to m times the sine of 45, which in this case gives you exactly the same thing. Okay, what I would recommend now is draw a picture looking at your beam, looking in this way. If we do that, we'll get some shape like this. And again, this is just rough. And you got this. And you ask yourself what's taking place at each of the corners. I'll define this corner here as being A, B, C, and D. Draw the axis system here. You have an axis coming across here. That is going to be your Z. Axis coming across here being your Y. Again, just not exactly in the center, but close enough. And you got Z here. You got Y here. Again, you can do a rough sketch. You know the moment is going to go up like this, and the Z is going to go this way in terms of along the Y. So what we could talk about here would be, let's talk about this one being the MY. Let me define these, MY and MZ. And MY will cause compression here. This is a good way to do it here. Just say MY, the compression due to Y. Here you got compression due to Y. Here you'd have tension due to Y, tension due to Y. Now you look here as a result of Z. We'd have tension as a result of Z. You'd have tension as a result of Z. Here you'd have compression as a result of Z, and compression as a result of Z. Here you have compression, compression, tension, tension. So the two critical points, I'll do this in blue, would be here and here. This is where you're going to get the maximum stress. So at this point, go ahead and find your moment of inertia. We'll find the moment of inertia around Z being the axis here. So in this case, you want this value here to be your height. And we do that, we will get 1/12 times the height of this beam, which is going to be 0.30 cubed. We'll multiply that times the base, which will be 0.15. Then we're going to subtract out all of this, which will be 1/12 times the height of this, which I think is 0.2. Let me get rid of this too. Move this out of the way so I got room here. Okay, so now we're back to 1/12 here, times 0.20 times 3 times 0.10. That'll give you a value of I, and the Z is being 2.7808 times 10 to the minus fourth. And that would be in meters to the fourth power. We'll do the same thing for I, Y. With IY being the axis here, this is going to be your height across here. This will be your base. So I do that, I get 1/12 times 0.150 cubed times the base, which is 0.30. We're going to subtract out this. Again, this will be the base of this. This will be the height. We'll run that number there, and we'll get IY is equal to 6.7708 times 10 to the minus 5 meters to the fourth. Now we can either use this point or this point. I'll just use A. It makes no difference whatsoever because you're going to add the two together. So we go back to MCI, and we know the stress is equal to the moment times the distance C over I. Again, that's a C. And when we do that, we would take the moment, which we know is 0.707 m. Okay, we will do let's do the y first. It makes no difference here. So if I'm going to do the y, I need to find out what this distance here is here. If you look at the picture, this distance from here to here would be 0.075 meters. We divide that by the moment inertia, 6.7708 times 10 to the minus 5. Now we will add that to this one, 0.707 m. That's the moment at z. Get the 1 in there, sorry. Times the distance it is from here to here, being from here to here to A. And that distance is 0.15. We'll divide it by the moment inertia of z, 2.7808 times 10 to the minus 4th. Now we know that's equal to the maximum stress is given as 6 megapascals, or 6 times 10 to the minus 6th. And now all you have to do is add these two together and solve for m. And when you do, you'll get an m value, a moment of 5106.88 Newton times meters, or basically 5.11 kilonewton times meters. And that's it. Pretty easy problem. Again, I highly recommend that you draw yourself a picture of the beam looking in and define what's taking place with the two moments, whether you're getting tension or compression. Obviously, when they add together, you're going to get your major stress. Okay?